Hi friends, welcome to the Unit 2 Day 8 notes. This section specifically talks about the algebra and composition of functions. When we have transformations to change a function graphically, we can also use two or more functions to change a graph, and it can create a new function algebraically. So when we do these operations on functions, we call this the algebra of functions. So if we say that f and g are functions with overlapping domains. Overlapping domains means you have the same possible x values in both, at least one value. So the notation for the operations of functions, if we're going to add the two operations together, f plus g of x, that is equal to f of x plus g of x. If we subtract the two functions, f minus g of x, it's the same as f of x minus g of x. And the domain is the result of the intersection of the two individual domains. So it's not the union, it's the intersection. So intersection means that you're going to have less values sometimes, depending on the situation. So here I've given you f of x equals 2x squared minus 3x, and then g of x equals 7x minus 2. So I said determine the domain of h of x, where h of x is subtracting these two. If I look at these two, the domain of this one, so the domain of f of x is going to be all real numbers. Remember, that's very simple for all real numbers. I can have any value I want. Remember, domain matters if we have a square root or an even root, really, or if we're dividing by some variable. And then the domain of g of x is also going to be all real numbers. So if I intersect these two, where is the intersection of all real numbers and all real numbers? Well, the domain of h of x, then, is going to be the intersection of both, so domain of h of x is also all real numbers. And remember, we can notate that in several ways. We can write it as an interval from negative infinity to infinity. We can write it as set notation, the set of x's, such that x is an element of the real numbers. Those are the two that we really focus on. It says find h of 2 using the definition. H of 2, well, if I think of what h of 2 is, so this is, now let's go ahead and show each of the steps. So here I have h of 2 is equal to, and then I have f minus g of 2. Well, f minus g is going to be f of 2 minus g of 2. Let's go ahead and then talk about what f of 2 is. So f of 2, I'm going to have 2 times 2 squared minus 3 times 2. So I'm using this bracket here as kind of a grouping symbol. I could use another set of parentheses. Minus, and then now g of 2. That's going to be 7 times 2 minus 2. So we need to do essentially what each part in these brackets first, and then we can simplify from there. So 2 squared is 4. 4 times 2 is 8, minus 6. 8 minus 6 is 2, minus 7 times 2 is 14. 14 minus 2 is 12, so 2 minus 12. 2 minus 12 is equal to negative 10. So h of 2 is negative 10. So let's find the new function h of x. So now we're going to say if it's f minus g, so h of x is equal to f minus g of x, then what we can do is we can take essentially 2x squared minus 3x, again, bracket here to show that we're grouping, minus, and then g of x, 7x minus 2. Really, the only thing we need to do here to simplify is to distribute the negative sign. So that's going to be 2x squared minus 3x plus negative 7x plus 2. Then combine like terms. So then I have 2x squared minus 10x plus 2. So this is now h of x. And then it says find h of 2 using the new function rule that we found in 3. So using this one here, h of 2 is equal to 2 times 2 squared minus 10 times 2 plus 2. 4 times 2 is 8, minus 20 plus 2. 8 minus 20 is negative 12. Negative 12 plus 2 is negative 10. And if you notice, these are the same, and they should be. We found We found it using the function rule, and then we found it using our original, using the definition. Join me in the next video as then I go over example 1. Have a great day.